Well, hello, scholars. Today we're going to look at the steps that we need to follow in order to graph a quadratic equation. Though we are going to do and come up with some of the quadratic equations using individual points, you can certainly use your graphing calculator or Desmos to help you with some of those. And then we're also going to take a look at a couple of characteristics, specifically the domain and range. So the steps here, you can see the first thing we're going to do is to find the axis of symmetry. Now, if you recall, to find the axis of symmetry, we have to use that formula that we're going to do, negative b over 2a. That will give us the vertical line that cuts the parabola in half, that is equal on both sides. And then we also want to find the vertex. And to find the vertex, we're just going to really just plug the x into the equation to find out the y value, and then we can have both the x and the y. Once we have the vertex, we can actually put that in the middle of the row of the table and then use our graphing calculator to come up with the rest of the values. Or we could use Desmos, one of the two, to do that. So, and then we're going to plot those points on the graph, and then of course we'll create the parabola. So let's just take a look at a pretty easy example of the most basic parabola, which is, or the most basic quadratic, which is y equals x squared. And so if we're going to look at y equals x squared, if you want to find where the axis of symmetry is, again, just use the formula. And so negative b over 2a will give us an axis of symmetry of 0, x equals 0. And notice that that's also the x coordinate of the vertex. Well, you plug 0 in for x squared, and you're going to get 0. So we know that the vertex is at 0, 0, so that's what we're going to do. We're going to put the vertex in the center of the table, and then what we want to do is just go a couple of x values to the left of it and a couple of values to the right. In other words, some ahead and below. So what we can do is we can use our graphing calculator. And so again, you should have graphing calculators either handheld, or you have one perhaps on your computer. And so let's just take a look at that one. So here I've pulled up what probably looks like your graphing calculator on the computer, and obviously the screen is over here, and if you want to type in an equation, just find the y equals key, and the y equals button will do that for us, and you can see that it will pull up values for that. So if you want to type in x squared, notice that you can either use well, the x value, you could either use the key or the one right next to the alpha button, and then you can either square it or you can raise it to the second power with the arrow key, either one. So the best way to type these in is just to type the equation in, exactly the one you want to do, and then if you notice up above the graph key in blue on my calculator is table, and so we're going to press the second key, and then we're going to press table, and we're going to go to a table. And notice that right now that table starts at 0, 0, and it goes, the x values go all the way up to 10. Now you can use the arrow keys if you want, and you can click on the arrow keys and you can back it up a little bit, and notice that this actually is the table that we're interested in for the table on our our graph. So you'll notice some symmetry here. So negative 2, that's going to be 4, 1, 0, 1, 4. And so if we go back to the graph and notice that we can put those numbers in, we're going to graph those. The axis of symmetry goes right through x equals 0, and that is a graph of y equals x squared. Okay. So one thing you'll notice is that when we talk about the domain and range, the domain, really we could put in any x values. It doesn't matter, even though the graph goes, we don't see the graph when we go with x values larger than 3 or 4. You can clearly plug in any value for x. So that's why our domain is going to be from negative infinity to positive infinity. You could also say all real numbers. I'm just using interval notation here. The other thing that you can see is the range. Because the vertex is a minimum, there are no values for this function below 0. So the outputs, the lowest output we're going to have is 0. So that's why, and it includes 0. So you'll notice I had a bracket here. And then it goes up to positive infinity because there's no maximum. The outputs will continue. So again, one of the things we want to pay attention to is domain and range of these functions as well. So let's take a look at the next example and notice that this is a trinomial. It has 3 terms to it, and so the first thing we want to find is the axis of symmetry. And so again, we're going to use b, which is 2, and we're going to use a, which is 1, and we're going to use the formula. And so the opposite of 2 over 2 times 1 is going to be -1. So that tells us that our axis of symmetry is that vertical line through -1. And then if we plug that value in, we'll find that the y value is -2. So our vertex then is -2. So let's go back to our graphing calculator and find the rest of these tables and see what this looks like. So again, here we are with our graphing calculator. Again, we go to our y equals. Notice I've already typed in the equation x squared plus 2x minus 1. So again, we'll just do second and then table, which is underneath the graph. So once we hit second and then graph, notice that we've got our table, and you want a couple of points. Here's our vertex. Notice that this is actually, again, the lowest point. You can see that the values increase from both of those sides. And so we just want a couple of points on either side of that. And so then we can record those back here. And so we'll give our values here, and we can plot those on the graph. And that gives us the parabola that we're looking for. And we'll go ahead and indicate that the vertex is at -1, -2. And then we talk about the domain and the range. Well, again, for quadratics, most of the time, the domain is going to be all real numbers from -infinity to positive infinity. In this case, notice that the vertex is, again, the minimum of the parabola. And so the lowest point on here is -2. And so you can see that, again, we're going to do that one as well. So again, just remember that I put the bracket here because, again, it includes -2 in the range, and that is going to give us the lowest point that it is, and so the range is limited from -2 to positive infinity. So notice that the next quadratic in this example is going to has a negative leading coefficient, which means that it is going to open down this time. And so again, let's start off by looking at the axis of symmetry. Again, if you want to work ahead on this one, you might want to press pause at this moment, and then go ahead and then press play when you're done filling in the problem. So as we take a look at this problem, we're going to again come up with b is -8 and a is -1. And so when we take the opposite of a negative number, we actually get a positive number. So that gives us 8 over -2, which is going to give us 4. So that's the axis of symmetry, and we can draw that axis of symmetry on the graph. And then if you plug that in, you'll get -1. And if you use your graphing calculator, we can find the table. And so notice that this table, in fact, the vertex is the maximum of the parabola. And so the very highest point is at -4, -1. And that would give us our vertex. So again, So it's not too surprising that the domain is from negative infinity to positive infinity. Again, all real numbers, no limitations for the domain, but the range is limited. Now notice that the minimum, there is no minimum this time because the highest point is -1. So that's going to be in our interval notation. We put that on the left or the right hand side over here with a bracket. And then the left-hand side, the lowest value, we will use negative infinity to indicate that there's no minimum for that. So that should give you a good indication on how to graph the parabolas in with quadratics that are in standard form. I do have some other examples for the last page of our notes, and I'll put that in a separate video for you if you want to practice a little bit before you start on your assignment. That's probably a great idea. You can check out the extra example video that is also in the folder.